Hello everyone, let's look at another exam question. So, an investor is deciding to invest in a project. Explain why the discounted payback period is a poorer decision criterion than net present value, assuming the investor is not short of capital. So I think the biggest thing we're looking at there is the fact that they've got a lot of money, and so why do they really care about when they're going to get paid back? So in this case, if they do have enough money, the discounted payback period wouldn't really make too much difference to someone. They just want to know which one's going to get them the most money, which is why we'd look at the net present value. So that's really the issue there. If they said they needed money by a certain amount of time, then of course we'd be looking at discounted payback period, and of course hoping that the net present value is always positive, and in fact as high as we'd like it. So let's go on to the next bit because that's simple enough. An investor is considering two projects, A and B. Project A involves investment of $1 million at the outset, and all they're going to get is $3.5 million after 10 years. Okay, so that's easy enough to work out. Project B also involves $1 million at outset, but they're going to be getting continuously 0.08 million in the first year, 0.09 in the second year, so it's going to go up by 0.01 million with every year until the 10th year, and after that, okay, that'll be all. So it wants to know the net present value of both investments at a rate of 4% per annum. Alright, well the first bit is easy enough. If we find the net present value of A, that's just going to be equal to negative 1 million plus 3.5 million discounted back 10 years. Whatever answer that is, we'll be able to find that out. In fact, I'll just look it up right now. So it's equal to negative 1 plus 3.5 divided by 1.04 to the power of 10, and that's then equal to, that is 1.3644. Okay, so we can note that down, and that's in millions, and that's in pounds as well. Alright, so we have that answer. Now let's look at the net present value of B. Alright, so a little trickier. We start off with a negative 1, but now we're looking at a continuously increasing annuity, and we know when doing something like that, we're going to be starting with, it's going to be like this, P plus Q, P minus Q, my mistake. So that'll be, P minus Q, where P is the starting value, so that's going to be 0.08. Q is the amount that it increases by, so 0.01. Then we're going to be doing that continuously, so that's going to go continuously over 10 years, that amount. So we just say we're going to be getting 0.07 every single year going ahead, continuously. And then after that, we'll be adding on some annuity that increases at a rate, so that's going to be Q, which is 0.01, and that then goes up at an increasingly continuous rate. So like this. And yeah, we'll just be adding on 0.01 going ahead. So in order to work this bit out, well, all we really need to do is just plug this in. So 0.08 minus 0.01, and that's going to be continuously over 10 years, plus 0.01 in increasing annuity over 10 years. Alright, so let's figure this out. I'm going to take out Excel, and I'm just going to do a few simple calculations, just some things that I might need. So that's going to be 0.04, this is going to be 0.04 divided by 1.04. V is always equal to 1 divided by 1.04. Delta is the natural log of 1 plus I. And I think that we've probably got enough there. So in order to find out this bit, a continuously increasing annuity, we just have to go, so this is just continuously increasing. So if I just say A cont, then I'm looking at equals 1 minus V to the n, which is 10 in this case, divided by delta, gives us that's the A continuous bit, and then we're going to be multiplying that by 0.07, or 0.08 minus 0.01. So we get that. That's an important answer here for us. And then to find out the increasing annuity bit, so we're looking at this bit over here, well that one we're then going to have to go and find out what A due is. So we're going to be looking at 1 minus V to the 10 divided by D is that, and then to find out the increasing A, we're going to be looking at this bit, sorry, in fact I'll put it in brackets, this bit minus NVN, so 10 times v to the 10, all divided by, and then that's delta over here, gives us this, and then we just multiply it by the 0.01, which is Q that we had before. And that's another important answer, and we can actually add these up. There's that. And then we're also minusing the one that we had at the start. So we're looking at an answer of 0.0073. Okay? So 0.0073 million. So it is positive. It's only just positive, but still positive. That's about 7,300 or so. Okay, so we've got our answers. That's that, and that's that. That's in pounds as well. Okay, so show that the discounted payback period for project A is after that of project B. No further calculation is necessary. So, even though we're earning more money, we've just got to ignore that fact and find out when are we getting this money. This money comes at the end of the 10th year. This money comes at some point before then. You might get your last dollar at the end of the 10th year. It might even be your last $1,000, but you will be getting some of this money even a second before the end of the 10th year, and therefore project B pays off quicker than project A. So what was the question again? Show that A is after B. Well, I mean, you can just note that down and explain that, and you can that's fairly straightforward to do. I mean, what I would normally do in this case is I would just draw a timeline and say that this is when project A is going to be complete, and project B will be at any point before then, and just write down explaining the nature of project B against project A. And then it says, so that was part 3. In the light of your answer to the first part, explain which project is more desirable to an investor with unlimited capital and why. Well, as we established in the first bit, if you've got unlimited capital, then it doesn't really matter when you're going to get your money, so the end of the 10th year is completely fine in our case, and given that A gives more money than B, quite clearly, then I'm going to be selecting project A. Alright, so thank you very much for watching, and I'll catch you next time.